In this video, I'm going to be unpacking two standards. I have chosen to unpack these standards because they are the standards for a lesson that I'm about to teach. These standards come from the Common Core State Standards for Math 8. We're going to be diving deep and looking at Standard 8FA3, where students give examples of functions that are not linear. We're also going to take a deeper look at Standard 8GC9, where scholars are expected to know the formulas for the volumes of cones, cylinders, and spheres and use them to solve real world and mathematical problems. Mastery metrics. Scholars are expected to know a piecewise linear function. Non-linear function is a function whose graph is pieced together out of line segments. They also need to know the volumes of a cylinder, cone, and sphere are V equals BH, V equals 1/3 pi r squared, V equals 4/3 pi r cubed, respectively. And volumes can be used to solve real world problems related to functions. Scholars are expected to provide examples of nonlinear functions using multiple representations, tables, graphs, and equations. They're also expected to state formulas of cones, cylinders, and spheres, and use formulas of cones, cylinders, and spheres to solve real world and mathematical problems. Big ideas. As we go through this unit, scholars need to really hone in on that functions can be represented in four different ways: algebraically, graphically, numerically in tables, and by verbal descriptions. Also, we have to always keep in mind that volume is a unit of measurement that indicates the number of cubic units a three-dimensional shape can hold. Essential questions. As we go through this unit, I will be constantly making sure that scholars are thinking about when should functions be evaluated and compared, why does one need to define a function, and how can one use volume to solve real world and mathematical problems? In order to get scholars motivated about the lesson, I have chosen to do a cross curricular lesson titled Sweet Tooth. The driving question for this lesson is: how much Halloween candy should you eat? Students will learn many people's enjoyment of something pleasurable like Halloween candy or income is not positively linear. More of a good thing is not always better. Students will interpret graphs of nonlinear functions, including discrete ones, and they're going to model nonlinear functions graphically. This lesson is broken down into two parts, Act 1 and Act 2. In Act 1, students interpret a graph and they share their expected marginal enjoyment over 10 pieces of candy. Act 2, students graph each person's total enjoyment and they watch an amazing video in which psychologist Daniel Kahneman describes the relationship between income and happiness. They relate the phenomenon of diminishing returns to candy and share other examples of diminishing returns. The next lesson that I'm going to focus on when I teach this unit has the driving question: what's the best size of disposable water bottle? Millions of tons of single-use plastic water bottles have ended up in the oceans and are wreaking havoc on wildlife. Scholars will use formulas for volume of a cylinder and volume of a sphere to solve real world problems. They're going to model with geometry and reason about surface area. This lesson is also broken up into two parts, Act 1 and Act 2. Students will approximate the volume of water bottles, calculate how many water bottles of each size one would need to drink, find the surface area of plastic, and identify consequences. In order to ensure that scholars are meeting the outlined standards, I have designed several assessments. Each day, scholars will engage in a daily cool down. My advanced level cool down example here shows where advanced level scholars are going to be able to use their advanced literacy level to solve problems about volume and surface area. Scholars who are on level will actually just use numbers and show me that they can calculate the volume. And scholars who are SPED scholars